change as the ruler moves away from your screen. Right? In the same way that the units from here to here is very much different from the actual ruler itself, but it's still describing the same thing that you see here. So from here, from this point to this point, I don't want to do it that way. I want to do it this way, because it'll make more sense later. Distance from this point to this point is 2 inches. It should be this way. The distance from this point to this point is -1 inch. The distance from this point to this point is +1 inch. Halfway between these 2 points gives us a fraction of 1/2, which equals 0.5 as an operation, which gives us the number 0.5, which in inches is 1/2 of an inch. So this is how it all comes together. I'm making this stuff up on the fly. So unfortunately, I cannot be a great entertainer and keep your attention by putting on a show, because I don't think that that's necessary with science. I think that sometimes we get more distracted with being entertained than we do with actually absorbing the information that's being put in front of us. So I don't want to distract you with entertainment. If you want to be entertained, you wouldn't be watching my videos. If you want to learn, then you would continue to watch my videos. These 2 points on this number line describe for you the universe. You can use this type of information to further explore your reality, your understanding of the world that you live in, which is the whole point of why I'm making these videos. Now, moving from this basic system into the next part of this understanding, because I have to keep my promise. What I'm going to do, what I plan on doing, is I plan on making a ruler. The ruler is going to be called a number line. As it stands right now, it's just an abstract concept. CON, something like that. It will have 10 units. Right? Yeah. It'll have 10 units. It'll have 10 units. These 10 units will be divided into 10 units, and each of those units will be divided into thirds. Wait, is that right? How can that be right? That's not right. It has to be 1/2, 3/4, and 1/4. I think that's right. 1/4, 1/2, 3/4. 1, 2, 3. Oh, I see what's going on. So I know what's going on. We'll leave it like this to avoid confusion. So this is this. This is this. And this is equal to 1. I'm sorry. This is equal to 1 standard inch. Right? This is going to be the my 02 cent ruler, but it's also going to be the my 02 cent number line. The way the my 02 cent number line is going to work is that 1 unit on my number line. So on a ruler, you have a ruler, 1 foot equals 12 inches, right? On a meter stick, 1 meter is equal to 10 centimeters. Yes, 10 centimeters. Is that right? No. 1 meter is equal to 30 centimeters. That's why it always confuses me. My 2 cent ruler is going to embody a abstract. No, it's going to embody a concrete number line. Right? So 1 number line is going to be equal to 10 units because they're undefined for you. They're defined for me, but for you, you don't know what they are. You don't, like, how can you know if I haven't even built the thing? So I'm going to say that they're defined by 10 units because the units themselves, like centimeters and inches, are still for you undefined until I define them right now. So 1 unit, the smallest unit, which will be equivalent to an inch, is going to be equal to 2.5 centimeters divided by 10. Divided by 10. So you divide that by 10 and you get the smallest unit, which is further divided into quarters, because it'll give you 3 divisions of 3, which will give you like, so it might make a little bit more sense if I just explain it this way instead of trying to illustrate it. So on this ruler you have an inch, right? So from this corner here to here is 1. Actually, okay. Alright. Alright, I found them. Whew. This one's kind of convenient. This is actually really ironic. This is the one I was working on, actually. So, as you can see from here, because this literally is the my 02 cent ruler, it's just not accurate. This is the one I've been actually trying to actually build. I don't know how that looks on camera because I haven't actually reviewed the footage. But basically, we have from this is the meter side. This is the inches side, right? And in the very center, we have the inaccurate numbers that I'm trying to describe. So from here to here is going to be equal to 2.5 meters. And these units are going to be divided into tens. So from here to here that'll be 10 units. And then an even more accurate number system, when you get into inches that go all the way down to 1/64, like I believe. Oh, how ironic is that? I never actually read this ruler. I never actually paid any attention to the fact that these actually are in millimeters. But as you can see, these really fine numbers, really fine lines, go really small. So you can divide. See if this makes any sense. I know this is like, what is this dude trying to say? But you can divide the units very finely, and that's what I want to do. I want to divide these units into 10, and then I'll explain why. I'll explain why right now. Because I want the whole point of that because that was a lot of extra, like literally a lot of extra for no real obvious reason. But the whole point of that is to get from the abstract to the concrete, right? We want to go from the abstract to the concrete. So then we have, I'm not going to draw the ruler. I'm not going to do all that stuff again. What I'm going to do is I'm going to do this. I'm going to go back to the basic number line. Just the basic number line. Remember pi? Pi is a relationship that gives you 3.14. What is, excuse me, pi, I need you to scoot over. I need you to move over for me. What is the difference between the relationship of these units and these units? The only difference is the understanding that we have living in a universe that has space that we must move through, that the difference between 1 unit and 10 units is time traveled. Okay, I'm going to say something extremely complicated, and hopefully I will say it correctly to convey my understanding. If I move at 1 unit per unit, okay, 1 mile per hour, right? If I'm moving at 1 mile per hour, it'll take me 1 hour to go from here to here. It'll take me 10 hours to go from here to here, right? If I'm moving at 10 miles an hour, it'll take me 1 hour to go from here to here. But it'll take me 1/10 of an hour to go from here to here. So what is 1/10 of an hour? 6 minutes. Based on our understood units of measuring both time and space. That's the importance of science. That's the reason why I care more about science than I do about religion. Because without a concrete understanding of what the units of time are and what the units of distance are, I cannot convey anything to you. I'd be like, hey, meet me at this location in space and time at this time. And you'll be like, okay. I'd be waiting for you. I'm like, well, what took you so long? And you'll be like, what are you talking about? Like, I've been here for like an hour. You'll be like, well, what's an hour? Like, I was just showering. It took me a certain length of time to conduct hygiene. And then when I came here, and then I headed this direction. And I'm like, well, you're kind of late because I had a time frame that I wanted to meet you here under. And you'll be like, well, I don't understand your time frame or your concept of numbers because I operate based on getting things done in a more concrete way. You're abstracting to me when I'm doing things concretely. That's pretty much the problem that we have in society, because you have one group of people doing things in the abstract while you have another group of people doing things in the concrete. But like always, I digress. I should just start saying that. Me digressing. But with these principles, you can do a lot of cool stuff. So the my 2 cent ruler wants to use 1/10 as a way. What you're looking at, okay, if you put 10 here and you put -10 here, this is my yardstick. Man. This would be the my 2 cent yardstick. And it would be however many, it'd be 2.5, it'd be 250 centimeters, roughly. and 150 of them would be on the positive, and 150 of them would be on the negative. And this device would be used to measure. And I keep trying to, it is my understanding that if you are a material person, you don't care about the abstract of a number line because it doesn't matter to you. You don't care. You literally just don't care, because when you sat in geometry and they were explaining to you all these numbers and lines and circles and triangles, they didn't matter because they're not concrete. But if you're a material person, you can clearly see the abstraction of a circle in something like duct tape. Because what is duct tape? Is it a circle or is it a line? Which one is it? Which one is it? Is it a circle or is it a line? You know the answer? The answer is the thing that made Einstein famous. It's relative. Everything is relative to how you are perceiving it at any given moment. It's all relative. And relative does not mean subject to abstraction. It means that to correctly interpret a thing at any given moment in time and space, you must perceive it correctly according to the information that it's giving you about itself. That is to say that water has 3 states: solid, liquid, and gas. You must perceive it relative to its state. If you find water in a solid state, then you must perceive that it is cold, or you must perceive that it is being influenced in a type of physical condition that will define it as being solid, which is not synonymous with the normal state or the average state that we perceive it in. So the point I'm trying to make is, if you come across solid water, water is usually a liquid under normal conditions that we perceive it. If you come across it in a solid state and it's not cold, something ain't right about the physics around it. Which means that you as a scientist should be like taking notes because you just discovered something new. But if you come across water and it's in a solid state and it's cold, well, it's just frozen. If you come across water and it's in a gaseous state and it is not hot, then it is in a state that is not considered normal for its state of being, except for the fact that water as a liquid can be heavily influenced by pressure. So water can vaporize in lower atmospheric pressure without needing more kinetic or thermal energy. So these relative principles is the reason why abstracting something like a number line becomes extremely important in understanding anything. The average Christian wants to tell me that God created the heavens and the earth in 7 days, which means that 7 times 24, which gives us 28, 14 plus 8, 168 hours. If I did that correctly. God created the heavens and the earth in 168 hours. But he rested on the seventh day. So now, since he took a rest on the 7th day, he created the earth in 144 hours. You give me an abstract concept, and then you tell me that I'm wrong for making it concrete when I live in a concrete world. And that's kind of like the last 30 minutes of me giving you abstract. That's how I feel. You're sitting here and you're watching me like, Emerson, why are you showing me, like Paul, why are you showing me all these crazy numbers and equations? And like, in the beginning, God created the heavens and the earth in 7 days. An abstract concept that instantly becomes concrete, right? So, again, that's the problem that we live in. That's the fundamental conflict with our universe. We're living as operating from a